Today I'm going to be showing you how you can build a generator in Create Power Grid. Now this does look like there's a lot of components, but don't worry, most of these are just to show how the system works and they're not necessary for the actual generator to function. So if you don't know how to build the generator itself, it's actually pretty straightforward. You just start off with some shafts. You connect them with some copper coil. Then you put your rotor in the middle and just surround it with more windings. Just like this. And to electrically connect the windings between them, you can use the generator housing like this. Now if you want, you can just leave it like this and it will work just fine. You do not need to connect all of them. It is just an aesthetic choice. In the back, you'll place your generator clutch, and in the front you can put the commutator. This is where you'll be taking off the energy generated. As you can see, it has a positive and a negative. And to actually power the windings themselves, you need to use a device connector. This one can be placed on the side or on the top or anywhere there's a flat surface where the coils are exposed. So that is your basic generator. You can build it from anywhere from 2 blocks all the way up to 8 blocks. The longer it is, the more stress it's going to require, but it's also going to generate a higher voltage. So do keep that in mind. So for the wiring, I would recommend using the insulated copper wire because it can be color coded. So from the generator, you'll take the positive lead into your carbon pile, from the carbon pile to a power resistor, and then into the positive side of the device connector. So I've seen people having issues with their generators not producing any power. That is most likely because they've connected the positive side of the generator to the negative input of the device connector, which will just make it not produce anything. If you want, you can add a current gauge so you can monitor the current that you give to your coils. It is important to note that you do not want to give your coils more than 2 amps. Doing so will just heat up the coils and not produce any more power, so it's just not worth it. Now, from your device connector, the negative can connect directly to your generator commutator. Now for controlling the carbon pile, you can come from your positive lead into your rheostat. You can connect it to the tap or the connector as long as it's these two or these two. Out of the rheostat you connect the carbon pile, one of the bottom connectors, and the other bottom connector goes to the negative. This should form your control circuit. So after you finished wiring up the carbon pile and the rheostat, let's set up the values. For the rheostat, just slide it all the way to 10,000. The power resistor 500 is just fine, at least for this size of generator. Okay, so after you set up your power resistor and rheostat, you can come in and trim the rheostat to around this area, around the middle point. You can actually click on the copper handle and set the amount of degrees per click. This way you can get finer adjustments instead of just 45 degrees. So after you trimmed your rheostat, you can come to the back of your generator and start feeding it rotational power. I will go ahead and just give it 240 RPM, that should be enough. As you can see, we are generating 1.1 kilovolts and consuming 158 watts. That is because of the small transformer that I have it connected to. So now using the rheostat we can trim the voltage however we want. If we need a lower voltage or a higher voltage, After the transformer, we're getting 285 volts, which is perfectly fine to feed in a basin heater. To power the basin heater, in theory you should be able to use a medium voltage switch, as it can support up to 32 amps, but I found that sometimes it will still burn out, so I would recommend using a contactor instead, which can go up to 64 amps. So now that we have power, we can go ahead and just switch on the basin heater, and as you can see it becomes superheated. And we're drawing over 7.5 kilowatts right now. And as you can see, the generator doesn't slow down or anything, which means we are not overloading the generator. If your generator does slow down, that means you are drawing too much power from it and your clutch is going to start to slip, which just means wasted power basically. So this is pretty much it for this tutorial. If you found it useful, please do let me know. And if you want to see any other tutorials from me, just write a comment saying what exactly you want me to cover, and I will see what I can do. So until then,